The next topic is pseudo first order reactions. Reactions which are not of first order but behave like first order under suitable conditions. Pseudo means false. So in such reactions, suppose we have A plus B to form product. Suppose A is in excess. Then the rate of reaction will not depend upon A. Then the rate of reaction will not depends upon A. So it means the rate of reaction that is directly proportional or depends only upon one reactant. So this is first order reaction. So like inversion of cane sugar is its example. Inversion of cane sugar. So cane sugar is C12H22O11. When you do the hydrolysis in the presence of acid, it will give you glucose and fructose. So this is cane sugar. This is glucose. This is fructose. So now in this case, rate of reaction, because water is present in excess, so rate only depends upon the concentration of the sucrose, or you can say cane sugar. So this reaction is an example of pseudo first order reaction. Here it's called inversion because this cane sugar is dextrorotatory. Its value is plus 66.5 degree, means it rotates light towards the right side with angle of 66.5 degree. This glucose is also dextrorotatory, but its value is plus 52.5. And this fructose is a leorotatory. So its value is in minus, that is in minus 92 degree. So overall, if you see, the reactant is dextrorotatory. It is ultimately going to change into a mixture of dextro and leo, in which the leorotatory is dominating. So overall this mixture is leo. So this dextro to leo is called inversion. So inversion of cane sugar is an example of pseudo first order reaction. Second example, hydrolysis of ester CH3COOC2H5. तो इसका हाइड्रोलिसिस करेंगे एसिडिक मीडियम में. So we get acetic acid and ethyl alcohol. So this is also an pseudo first order reaction because in this case also rate is directly proportional to concentration of this, as water is taken as the concentration of water is constant. So this is also the first order reaction. Now we will derive the rate equation for these two reactions. तो पहले हम इसी के लिए कर लेते हैं hydrolysis of ester. So kinetic of this pseudo first order reaction is studied by estimating the amount of acid present in the mixture. So study कैसे करेंगे? By estimation of amount of acid present in mixture by titrating against NaOH. वो टाइट्रेट करके पता चल जाएगा. तो वॉल्यूम ऑफ बेस इनिशियली यूज्ड by titrating the portion of reaction mixture in the presence of suitable indicator that will corresponding to the acid acting as catalyst. तो जितनी अमाउंट हम इनिशियली लेंगे, ओके, तो कितनी यूज होगी वॉल्यूम ऑफ NaOH used in any NaOH used in the beginning, or you can say when the time is 0, or that is written as V0, that will be directly proportional to amount of acid present at catalyst. ये जो acid पहले से ही present है उसकी amount पे depend करेगा. Acid present as a catalyst. So V0 directly proportional to amount of acid present as catalyst. Next is the volume of NaOH used at any time, means T equal to T, ये हो जाएगा VT. That is directly proportional to amount of catalyst, वो तो है ही present पहले से, plus amount of acetic acid produced, दोनों के directly proportional होगा. Amount of catalyst plus amount of acetic acid produced, जो acetic acid इस रिएक्शन में प्रोड्यूस हो रहा है, दोनों की सम. तो अमाउंट ऑफ एसिटिक एसिड प्रोड्यूस्ड इसकी इक्वल होगा फिर अमाउंट ऑफ एसिटिक एसिड प्रोड्यूस्ड. दिस विल बी इक्वल टू एट एनी टाइम टी Vt minus V0 at any time directly proportional to Vt minus V0. Okay. So, what amount of acetic acid produced at any instance is directly proportional to amount of ester formed. Amount of ester reacted. कितना जितना acetic acid बनेगा उतना ही ये ester जो है वो react करेगा. तो this is also directly proportional to, you can say, amount of ester reacted. So this we can write X directly proportional to X is the amount of ester which is reacted. Okay. Now amount of acid as a catalyst plus maximum amount of acid, टोटल कितना NaOH जो है वो यूज होगा वो हम अब कैलकुलेट करेंगे नेक्स्ट में. So this is the now volume of NaOH used when reaction proceed for about 24 hours or infinite time, that is V infinity. That directly proportional to amount of catalyst. पहले था जो एसिड और मैक्सिमम अमाउंट, अब इसकी जो अमाउंट है वो मैक्सिमम होगी. तो मैक्सिमम अमाउंट ऑफ एसिटिक एसिड प्रोड्यूस दैट इज डायरेक्टली प्रोपोर्शनल टू V infinity माइनस V0. V0 क्या है? अमाउंट ऑफ एसिटिक एसिड जो पहले से प्रेजेंट था, जो यहाँ पे लिखा है एसिटिक एसिड कैटालिस्ट. तो A डायरेक्टली A क्यों? बिकॉज जितना मैक्सिमम अमाउंट ऑफ एसिटिक एसिड जो प्रोड्यूस होगा रिएक्शन में दैट इज डायरेक्टली प्रोपोर्शनल टू जितना हमने एस्टर लिया था. तो दैट एस्टर की इनिशियल कंसंट्रेशन A is directly proportional to V infinity minus V0. यहाँ से हम A minus X निकालेंगे. तो ये जो वैल्यूज हैं A की और A minus X की इस फर्स्ट ऑर्डर किनेटिक्स में पुट कर देंगे. तो दिस इज योर रेट कांस्टेंट रेट इक्वेशन फॉर द हाइड्रोलिसिस ऑफ एस्टर. ऐसी जो पहले की थी रिएक्शन हमने इन्वर्शन ऑफ केन शुगर, उसका भी ऐसे ही है. ये था इन्वर्शन ऑफ केन शुगर। इसको हम कैसे करेंगे? कंसंट्रेशन ऑफ ऑल द रिएक्टेंट सुक्रोज वाटर कैटलिस्ट आर टू बी कंसिडर्ड। The reaction must be third order, but in actual it follows first order kinetic. That's why it is a pseudo first order. Since sucrose undergoing change in the specific rotation as a result of inversion, its kinetics can be studied by noting the rotation. So study can be done by noting the optical rotation. Because sucrose is going to change from D to L at the various times with the help of instrument, उसको बोलते हैं पोलैरीमीटर। तो इस रिएक्शन का किनेटिक्स जो हम पोलैरीमीटर से स्टडी करेंगे, ऑप्टिकल रोटेशन को नोट करेंगे। सो रीडिंग एट टाइम t0, time t0, this will be, you can say is r0, r0. Reading at time, at certain time, okay, when the time is tt, the reading become rt. Okay. So reading at infinite time, when the time is infinity, so you will take it r infinity. So reaction is supposed to complete at infinite time, say 24 hours. So initial concentration of sucrose, या केन शुगर लिख सकते हैं, केन शुगर। तो इनिशियल कंसंट्रेशन जो है इसकी, जिसको हम A से लिखते हैं, दैट विल बी इक्वल टू R at time 0 and at time infinity, है ना, R0 minus R infinity, इसके इक्वल हो जाएगी। And decrease in concentration of sucrose at time t, decrease in concentration of sucrose, or you can say cane sugar, at any time t. This is x. Okay, and this will be equal to r naught, this is equal to x actually, so minus r t, r naught minus r t. So a minus x यहाँ से हम कैलकुलेट कर लेंगे। a की वैल्यू है हमारी r naught minus r infinity, इसकी वैल्यू है r naught minus r t, तो ये बन जाएगा RT minus R infinity. So now put in the equation. So our equation of first order kinetics is K 2.303 T log A by A minus X. So just put the values. It become 2.303 K T log A की value R naught minus R infinity, और a minus x की वैल्यू rt minus r infinity. So this is the rate constant, value of rate constant k for the inversion of cane sugar. Next is calculation of rate constant for first order reaction carried in gaseous phase. So suppose a reaction is there, A change into B and C in gaseous state. Let the initial pressure of A is Pi. I means initial. Total pressure at time t say it is PT. Okay. So if PA, PB and PC be the total pressure, partial pressure of the species, so 3 gases हैं, PA, PB, PC. These are the partial pressures. Then what will be the total pressure according to Dalton's law of partial pressure? The sum of these 3 partial pressure become equal to the total pressure. Now, so this is your A going to change into B and C now. Now if the T is 0, your pressure is PI, and we assume unit of pressure is ATM. B is not there, C is not there initially. So pressure of B is 0. You can put it like 0, 0. So at T equal to T, after some time, some amount of X that decompose to give B and C. It means the pressure of A get reduced. So it become now Pi minus X. Pressure of B and C become X ATM and X ATM. So what will be the total pressure at this time? That is equal to PA minus X plus X plus X. So this is equal to PI plus X. So PT become equal to PI plus X ATM. This is the total pressure at time T. Now we know that first order reaction is K equal to 2.303 by T log. At the upper end we have a initial concentration, and at the lower end we have a concentration at time T. So here we have initial pressure. Generally we write it like this. So now A0 is corresponding, A0 means your A. This is corresponding to your initial pressure, that is Pi. That final A minus X, what is A here? That is Pi naught. And what is X here? You can find out X from here. It will be equal to PT minus Pi. Okay, it's PT minus Pi. So what is A? A is Pi. What is A minus X? You can find out A minus X. A is Pi minus X. PT minus Pi. So this become equal to 2 Pi minus PT. 2 Pi minus PT. So just put the value in this equation. What is now K? Is 2.303 by T log. Here we have a Pi. Here we have a 2 Pi minus PT. So this is the rate K, that is the rate constant for the reaction in the gaseous phase. So this we can calculate. Next, some examples of first order kinetics basically. There are some questions related to this first order kinetics. So first problem is a first order reaction is found to found to have a rate constant K 5.5 10 is per minus 40 per second. Find half-life. So there is a direct relation between half-life and rate constant. Just put the value. 0.693 divided by 5.5 into 10 is per minus 14. And you get 1.26 10 is per 13. Second. Question number 2. 3/4 of the first order reaction is completed in 32 minutes. What is the half-life? So, for this type of reaction, we know the rate constant for half-life is 2.303 by T log A upon A minus X. So, if we assume A is 100 initial, what will be your X? 3/4 of the reaction is completed. 3/4 means 75% is completed. Well, then what will be the X? It means 75. What is A minus X? That is your 25. So you can put the value in this equation to get K. Okay, so what is K? Is 2.303 by T. T is given 32 minutes. Log 100 by 25. ये 4 हो जाएगा. तो 2.303 by 32 log 4. 2.303 by 32 log 4 is 0.6. And to calculate it becomes 0.043. So your K comes out to be 0.043. मिनट में है तो पर मिनट इसका यूनिट हो जाएगा. Now we have to find out the half-life period. Half-life is 0.693 by K. Now K, we have a K 0.043. So half-life come out to be about 16 minutes. In this way you can calculate the problems. Third problem is first order reaction is 20% complete. In 10 minutes. Calculate the time for the completion of 75%. Calculate time for the completion of 75% reaction. Again, it is a first order reaction. For for T 20%, you can write the reaction for equation like this: 2.303 K log 100 by, as 20% is completed, A minus X is 80. From here we can calculate K. What is time? 10 minutes. 2.303 by k log 5 by 4. So this is about log 1.25. Now write the equation for 75%. So T 75% is k log 100 by 25. So this time we have to calculate. It is 2.303 by k log 4. So this is T 75%. Now divide T 75. This is your equation number 1. This is 2. So divide 2 by 1. T 75% equal to 10. नीचे की 20 का आ गया 10. ऊपर आ जाएगा log 4. k से k कट जाएगा. log 4 log 5 by 4. So log 4 is 5 by 4 become 1.25. So log 4 is, so T 75% क्या बन जाएगा? log 4 upon log 1.25 into 10. तो log 4 जो है वो आ गया हमारा 0.60. 1.25 का log आप log टेबल में से देखोगे वो आ जाएगा 0.97 into 10. कैलकुलेट करने के बाद आपके पास आंसर आ गया 62.14 minutes. So in this way you can calculate, you can solve the problem related to the first order. One more is there. Find out 2/3 life of first order reaction. In which k is rate constant is given 5.48 10 as per 14. 5.48 10 is per minus 40 per second. So 2/3 of reaction is we have to calculate. So now initial concentration is A. Concentration at time t is A minus x. What is x? X is 2 by 3A. So this is the rate constant equation for first order. Just put the value to find out the T2 by 3. Now we have a T2 by 3. It become equal to 2 by 303 k log A minus 2 by 3A. So it comes out to be T2 by 3 2.303 k log A upon 1 by 3A. A कट जाएगा 3 ऊपर चला गया. T2 by 3 is 2.303. Value of k is here log 3. So T2 by 3 is 2.303 divide 5.48 that is per minus 14. Log 3 is 0.48. So when you solve it, you will get 2 into 10 is per 13 second. So this is 2/3 life of the reaction. So such type of problems are there. हैं।